Hello dear students, I welcome you all to another session of chapter on circles. Now let us see the first question of the day. The question says, in the figure, O is the center of the circle. Angle AOE is 150 degree, angle DAO is 51 degree. Okay, so this is the given circle with center O. Now it is given that AOE, that is AOE means this angle is given to be 150 degree, right? And DAO, that is DAO means this angle is given to be 51 degree. All right, now we need to calculate the sizes of the angle CEB. So let's see where is CEB. So CEB is out here, so we need to calculate this angle. All right, and we need to calculate OCE. So OCE means we need to calculate how much is this angle. All right, now let's begin with the sum. Okay, so in the figure it is clearly seen that these two things are given. All right, now AOE, that is this angle is 150 degree, right? And DAO, that is DAO means this is given to be 51 degree. All right, now let us have a look at A, B, E and D. Now all of them lie in the circumference, so that's why this has to be a cyclic quadrilateral. All right, now if this is a cyclic quadrilateral, we need to calculate something called CEB, that is this angle, right? So if I extend this line, then this becomes my exterior angle, right? And one of the theorem from cyclic quadrilateral says that this external angle will be equals to opposite interior angle, that is this one, isn't it? Now this is my external, then opposite interior becomes this one. All right, so CEB, that is this angle and this angle, both are going to be equal, and we already know the value of this angle, which is how much? 51 degree. All right, so that's why in cyclic quadrilateral, this one, that is external CEB, that is this will be equals to interior opposite DAO, which is equals to 51 degree. So that means the value for angle CEB is nothing but 51 degree. All right, now let us move on to the next part, that is to calculate OCE. That is OCE means we need to calculate this angle. All right, so let us calculate this angle. Now in triangle OEB, this triangle, now in this triangle what is happening is, this is my exterior angle, okay, exterior angle AOE, and we know that exterior angle will be equals to sum of the opposite interior. Now this is exterior and opposite interiors are this one and this one, right? So that is OBE, this OBE, and this is OEB. Now one more thing, in this particular triangle, this side and this side both has to be equal. You know why? Because they are radii. Yes or no? Okay, so since this and this are radii of the circle, so that's why they have to be equal. So that's why this angle and this angle, they will also be equal, because this is isosceles triangle. Okay, so that's why instead of OEB I have written OBE here. All right, because OB is equals to OE. All right, so after adding these I'll get 2 OBE. Now we know that this external is equals to how much? This is equals to 150, right? So that means this 150 is equals to 2 times OB, that is 2 times OB is equals to 150. So what is the value of OB? So OB is 75 degrees. So that means this angle is 75 degree. All right, now let us calculate this angle. We can definitely calculate this angle. Now this will be nothing but 180 minus this part, right? This is a straight line, and from straight angle I have to subtract this one in order to get this one. All right, so that's why EBC. So EBC is equals to 180 minus this part, which is 75. So this turns out to be 105. So this is 105, and we already know this is 51, right? So at last we need to calculate this one. OCE means we need to calculate this. Now in triangle EBC, okay, so in triangle EBC, some of the interior angles will be 180 degree, right? So we already know CEB, which is 51 degree. We already know OCE. No, we don't know OCE, but we know EBC, right? So let us put the value of EBC. So if I do that, then the value of OCE turns out to be 24 degree. Alright, so pause the video to note down. Okay, let's have a look at the next question. So question says, in the figure given below, P and Q are the arcs of the center of two circles intersecting at B and C. So there are two circles with center P and Q, and both of them gets intersected at B and C. And ACD is a straight line. So ACD, that is a line passing through the C, is a straight line. Now we need to calculate the numerical value of x. Alright. Okay, now let us go to the first circle. Now in first circle, let us see arc AB. Okay, so arc AB subtends angle APB with the center, right? Okay, and in the remaining part, the AB subtends angle ACB. That means this angle will be double of this, right? So that's what is happening out here. All right, so as I said, APB will be double of ACB. All right, so that's what is written. So that means ACB can be written as half of APB. All right, now we know what is APB. APB is given to be how much? It is 150. Okay, so instead of APB I have written 150, so this turns out to be 75. That means this angle is how much? 75 degree. All right, but we need to go to another circle because we need to calculate the value of x. Okay, so from here let us shift to this one. Now we know that this is a straight line, right? So that's why, as I said earlier, this angle will be nothing but 180, that is straight line minus this. All right, so that's what I have written. Okay, so ACB, this plus this will be equals to 180 because they are linear pair. Okay, so DCB turns out to be 180 minus angle ACB, right? And what is angle ACB? This turned out to be 75. All right, so this turns out to be 105. So this angle, that is DCB, is equals to how much? 105. Okay, now let us go to the same theorem which we have used in this case. All right, now in this circle, let us have a look at BD. Okay, so this BD subtends angle BQD with the center Q. All right, and in the remaining part, it subtends angle BCD, or you can call it DCB as well. All right, so in other words, we can say that this angle will be double of this. All right, so that's what is written out here. All right, so we have BQD, that is this one, will be equals to double of this, right? And how much is DCB? So this turned out to be 105 from here. Okay, so this is equals to 210. That means the value of this angle is 210. Now we know that if I add x and this, I'll get a full 360 degree angle, right? So that's why I've written this x plus from here to here is 210. So x plus 210, that is BQD, will be equals to 360. All right, so from here calculate the value of x, which turns out to be 150. All right, so pause the video to note down. Okay, let's have a look at the next problem, that is question 33. The figure shows two circles intersect at A and B. Okay, so don't get confused with the figure. So what is happening is, there are two circles. This is a smaller circle and there is a bigger circle. All right, so both of them gets intersected at A and B. All right, okay, now it is said that the center of the smaller circle is O. All right, so this is my small circle and center is O. All right, and lies on the circumference of the larger circle. That means the center of the smaller circle lies on the circumference of the bigger circle, isn't it? So it is clearly seen that the center is lying in the circumference of the bigger circle. Okay, now it is given that angle APB is given to be a degree. So you need to calculate in terms of a degree. Okay, so our answer will come in terms of a degree, the value of obtuse AOB. So where is AOB? AOB is this angle. All right, so we need to calculate the value of this angle. Next is ACB. So ACB means this angle. All right, and next is ADB. So ADB means this angle. So basically we need to calculate this and this. All right, now let us begin. Now we have arc AB in the smallest circle subtends angle AOB at the center. That means in the smaller circle this AB arc is there. Okay, so forget about other circle and other lines. Let us get interested only with the remaining thing, that is this part. All right, now this is my AB arc, right, and this AB subtends angle AOB with the center. Okay, and in the remaining part, that is in this part, this AB subtends APB, isn't it? That means this angle has to be double of this part. All right, so we have angle AOB will be equals to double of APB, right? And how much is APB? APB is a degree, right? So that's why we have, instead of APB, I am writing a degree. All right, so my answer for this particular question, that is optics AOB, will be double the a degree. All right, so this is my first answer. Now let us find the second answer. That is second answer, that ACB lies in the bigger circle, right? So let us go to bigger circle. So we need to calculate this one. Now if you see here carefully, in this bigger circle, A, O, B and C, all of them lie in the circumference. So that's why AOBC can be considered as cyclic quadrilateral. All right, okay, so in larger circle we have AOBC is a cyclic quadrilateral. Okay, now in cyclic quadrilateral we know that some of the opposite angles, that is this and this, they are in the opposite direction, right? So sum of them will be equals to 180 degree. So that's what is written here. So AOB, that is this, plus ACB, that is this, will get added to 180 degree. All right, and what is AOB? AOB is 2A, right? So we have from here ACB equals to 180 minus 2A degree. All right, okay, so let us go to the last part. So this is also found. Now this is the last part. Okay, now if I call this AB, okay, so if I join this line, then this AB divides the circle into two segments. Okay, so in this segment, this part, AB is forming two angles, that is ACB and another is ADB. Okay, and they will always be equal because they are angles in the same segment, right? So since ACB and ADB are in the same segment, they must be equal to each other, right? And we know that ACB is equals to 180 minus 2A. So that's why ADB will also be 180 minus 2A. All right, so pause the video to note down. Okay, let's move on to the fourth question of the day. So question C is, in the given figure, O is the center of the circle. Okay, and angle ABC is given to 55 degree. So we need to calculate the value of X and Y. All right, so let us begin with the sum. Now let us have a look at this triangle carefully, that is OBC. All right, now OB and OC are the radius or radii, right? So that's why they must be equal. That means OBC is is an isosceles triangle. Okay, so in this case these two are equal, means this angle and this angle has to be equal, right? Okay, so that's what is written out here, right? So OBC, that is OBC and BCO, both are equal. All right, now OBC, this is this angle, right? So OBC can also be written as ABC. All right, so instead of OBC it is written ABC. So ABC is equals to BCO. All right, so we know that ABC is given to 55 degrees, right? All right, so that's why we have BCO also equals to 55 degree. All right, okay, now we have in triangle OBC. Okay, so triangle OBC, this is your exterior angle. All right, so if I extend this line, I'll get this as the exterior line, exterior angle, and we know that this exterior angle will be equals to sum of the opposite interior angles. So this one and this one are opposite interior angles. All right, so exterior AOC, that is this, will be equals to OBC, this one, plus BCO, that is this one. All right, okay, so both of them are 55. So that's why 55 plus 55 is 110. So this has to be, exterior angle has to be 110. And what is this actually? This is nothing but Rx. So that's why the value for X turns out to be 110. Okay, now at last we need to calculate the value of Y, isn't it? Now if I see here A, D, C and B, all of them lie in the circumference. So that's why I can call ABCD to be a cyclic quadrilateral. And in cyclic quadrilateral, sum of the opposite, that is this one and this one, will be equals to how much? It will be 180. Alright, so in cyclic quadrilateral ABCD we have ADC, so this angle plus ABC, that is this angle, will be equals to 180 degree. Alright, so let's put the value. So ADC is y, ABC is 55, so from here y turns out to be 125 degree. Alright, so pause the video to note down. Okay, let's move on to the last question of the day. So question says, in the given figure, A is the center of the circle. Okay, ABCD is a parallelogram. So ABCD is a parallelogram. That means this one and this one are parallel, and this one and this one are parallel. Alright, and CDE is a straight line. So this is a straight line. Alright, now we know that this line and this line both are parallel because they are opposite sides of a parallelogram. Now if AB and CD are parallel, if this and this are parallel, then this and this also has to be parallel because this is the same line which is extended out here, right? So that's why this and this both will be parallel. Alright, so we need to prove that BCD will be equals to 2 times AB. So BCD. Alright, so this angle will be double of ABE, that is ABE, that is this angle. So this will be double of this one. That's what we need to show out here. Alright, so let's begin. So here we have AB is parallel to DC, right? Alright, and okay, so that's what I said. If these two are parallel, then this and this will also be parallel. Okay, now if these two are parallel, then this BE acts like my transversal, right? So if this is my transversal, then this angle and this angle, they are called alternate angles, so they will be equal to each other. So that's why it is written ABE will be equals to BED. Alright, so these two are equal because they are alternate angles. Okay, now in this parallelogram ABCD, we know that BAD, this one, this angle and this angle, they will be equal because they are opposite angles of a parallelogram. Remember, in a parallelogram the opposite angles will always be equal. Okay, so that's why it is written BAD, that is this angle, is equals to BCD. Alright, okay, now this BD is subtending angle BAD with the center. Okay, and in the remaining part of the circle, that is in this part, this BD is subtending angle BED, right? So we have this BED will be just half of this. Alright, so that's why it is written this BAD is double of this one, that is BED. Alright, okay, so let us make use of 1 and 2 here. Now what is BAD? So BAD is equals to BCD. Instead of BAD I am writing BCD, and what is BED? BED is AB. Alright, so that's why instead of BAD I am writing BCD, and instead of BED I am writing ABE. Okay, so that's what we need to prove out here. Alright, so pause the video to note down. Thank you very much.